ABCD is a trapezium with BC parallel to AD. E is the point on AD such that BE is perpendicular to AD. BDA is equal to 55 degrees, AE is equal to 7 centimeter, BE is equals to 18 centimeter, and BC is equals to 9 centimeter. Calculate BAE. Okay, so the if you look at the diagram, all the information is already given. This is the angle which we have to find out. So we are going to consider this right angle triangle right now for the calculation of that angle. I am going to use this triangle which I am highlighting with the red. This is the triangle which we'll be using, at least for part 1 only. So let's solve it over here. I have to find out the value of this angle. And in this triangle, I know 18. 18 becomes the opposite, and I know 7, which becomes the adjacent. So I can use tangent to find out that angle. I'll say tangent angle BAE is equal to opposite upon adjacent. Opposite is 18 and adjacent is 7. So let's divide 18 with 7. First of all, this is going to be 2.57. I can say tangent angle BAE is equal to 2.57, and to find out the value of angle BAE, I'll remove the tangent and I'll move it to this side. It becomes tangent inverse 2.57. So let's take tangent inverse of 2.57. That is going to be 68.75. So angle BAE is equal to 68.75 degrees, right? Moving on to the next part. The next part says the area of the trapezium ABCD. Okay, the area of the trapezium. The formula for the area of trapezium is equals to, let me write the formula. The formula for the area of trapezium is equals to A is equals to 1 upon 2 multiply by height of the trapezium multiply by the sum of parallel sides. Let me write it as A plus B, or I could have written sum of parallel sides as well. So I have the height of the trapezium, which is 18. I have one of the parallel sides, but I do not have the other parallel sides. The other parallel side is AD. I do not have AD. I have AE, but I'm missing this part. If I knew ED, I would say that I have the entire length. So before I start finding the area of the trapezium, I'll have to find out the value of ED. For ED, I am going to consider triangle BED. I'll consider triangle BED and I'll use tangent to find out the length of ED. I have 55 degrees in that triangle, so I'll say tangent 55 equals to opposite of that triangle again is 18 divided by ED. I'll simply move ED to this side and bring tangent 55 over here. Then ED is going to be 18 divided by whatever is the value of tangent 55. So I'll write tangent 55 is equal to 1.42. Let's divide 18 with this value. We get 12.6. The length of ED is equal to 12.6. So this half is 12.6, means the entire length is going to be 19.6. 12.6 plus 7 is going to be 19.6. Now we can go on and find the area of the trapezium, which says area of the trapezium equals to 1 upon 2 multiply by the height of the trapezium, which is 18 in this case, multiply by the sum of parallel sides. The parallel sides are 9 and 19.6. The sum of these two is 9 plus 19.6. Let's cancel this 2 with this 18. I get 9. This is 9. Multiply by 9 plus 19.6. So this is going to be 28.6. I am going to multiply 28.6 with 9. I am getting 257.4. So the area of the trapezium is 257.4 centimeter squared.